So hey guys, in this video we are going to learn what orthogonal transformation, okay, which is related to the quadratic form. So we have given the question that to reduce the quadratic form, which is given over here, to the canonical form using the orthogonal transformation, okay. So here what we need to understand, first we have to convert this quadratic form into matrix. Symmetric matrix will be formed. That we'll name it as A. So let us first convert that. So direct, no formula, directly you are going to convert. How to convert, let us see. So whatever the A matrix is there, that will be 3 cross 3. Why 3 cross 3? Because here how many variables are involved in quadratic form? X1 is there, X2 is there, X3 is there. That means 3 variables. Therefore, it will be 3 cross 3 matrix. That means 3 rows and 3 columns, square matrix. So here I will form the square matrix, which is 3 cross 3. Now the column wise you write x1, x2 and x3 variables, and row wise also x1, x2 and x3. Simple. Okay. Now carefully you have to see here x1 square is sitting. See, whenever square comes you have to understand that it will be diagonal elements. Okay, anyways I'll explain here. So x1 square means what? X1 is multiplied twice. So here x1 is sitting, here x1 is sitting. When you multiply both, you will be getting what? X1 square. So that particular element will come here because x1 here first row, first column, where it will come? This element here. So that particular coefficient you have to write. That is nothing but the first diagonal element. Simple. That's why I said it is basically square. When it comes, it is diagonal element. Next, x2 square is also there, right? So x2 square means what? x2 into x2. So that particular thing will come over here, this particular space. So it will be the second diagonal element. Then just to coefficient you have to copy paste. Okay, so x3 square is there, so x3 into x3, that will be the third diagonal element, right? So just copy paste. Next, coming to the next part, x1 and x3 is there, only x1 and x3 is there. Now the question arises, x1 is sitting here, x3 is sitting here, but one more x1 and x3 is sitting here. So which one, where should I write that? That is the question, right? Now always remember the diagonal elements directly you can copy paste whatever the coefficient is there. Rest all terms you have to always take half of that particular coefficient. Half of means what? Here 2 is sitting, you have to take half of that, which becomes 1. So 1 you have to place it where? Both the places. That means x1 and x3 is sitting. So here also is possibility is there. x3 and x1 is sitting. So here also possibility is there. So both place you have to place what? 1. Simple. Now there is no doubt half of, but remember half of. Rest all places always it is half of the coefficient. Okay. If they give you x2 and x3, and that means what? x2 and x3, here it will come, and one more x2 and x3 is there, x2 and x3 here also. So both the places it will be the same thing. That you have to understand. So what about rest all terms? You just write 0, 0, 0, 0 because that is not given. Rest terms is not given in the quadratic form. So the A matrix is done. Symmetric matrix is formed. Symmetric why? Because if you take the transpose of this, if I take A transpose, it will be same as A. Transpose in the sense what? Row will be transformed into column. Column becomes row. That's it. Now this is general part of this thing. The congruent transform also same step we have followed. Okay, this is the first step, we can name it. Now we'll go for the second step, very important step. In orthogonal transformation we have to find the eigenvalue and corresponding eigenvector of this particular A matrix, which is symmetric matrix. Okay, so eigenvalue and eigenvector, I hope you know how to find out. So step 2 is basically to find out the eigenvalue and corresponding eigenvector. Now how to find that? That is the question. So eigenvalue can be found out using the, so this is 3 cross 3 matrix. So we know how to find out the eigenvalue. So we can go by the first method. Two methods are there. First you have to find out the characteristic equation. After characteristic equation, from that solving that equation you will be arriving at eigenvalues. That eigenvalues when you take, first you have to get the characteristic equation, right? So let me just write here step characteristic equation. After characteristic equation, when you solve this equation, you will get eigenvalue, and each eigenvalue you will take and you are going to put it in the form of a minus lambda x. That form we will study that. So you will be getting what eigenvector. Then after using eigenvector, we are going to get the orthogonal transformation. This is the procedure. Okay. So characteristic equation in the sense what? Two ways it can be found out. First way is a minus lambda I determinant equal to 0 you have to put. Where A is the given matrix, here it is a matrix, lambda is the eigenvalue, I is the identity matrix of the same form, here it is 3 cross 3 means it is also 3 cross 3. Now, second method is by using the formula lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. This is another formula. So we have made many videos based on this. Okay. So anyways, in this video we are going with what the first method. Second method, if you want to try, you can watch that particular video how to find using this formula method. Anyways, we are going with the first method, traditional method. Okay. So a minus lambda is equal to 0. So whatever the A matrix is there, so I'm going to teach you the simple technique. So a minus lambda I, how to write directly. Simple technique. What you have to do? A matrix is this one. Wherever the diagonal elements is there, subtract that with what? Minus lambda. You put minus lambda beside that. So diagonal elements 2 to 2 is there. Put minus lambda and write that form. It will become a minus lambda I. Okay. No need to go for a, then minus lambda, then I. No need to go for that. Directly you are going to write. So a minus lambda I. First we will write the matrix. So it becomes 2 minus lambda 0 1 0 2 minus lambda 0 1 0 2 minus lambda. Okay. So this we wrote 3 cross 3 matrix we wrote. So as I said, no need to bother about this thing. Directly diagonal elements just put minus lambda minus lambda minus lambda. Okay. Now this particular matrix I have to take the determinant and put it equal to 0. Simple thing. So I'm going to take the determinant of this. Okay, determinant symbol I put equal to 0 you have to put. So this matrix determinant how to take, I hope you have studied. So first row I am going to expand. Okay, so the first element is 2 minus lambda. So I am going to write what? 2 minus lambda into, leave this row and column. What is left out? This, we have to take the determinant. So this into this minus this into this, right? So it will be 2 minus lambda into 2 minus lambda minus 0 into 0. No need to write that. Okay. Next, second element, whenever you are taking, you have to put minus sign. Now the thing here is that 0 is sitting. So 0 into anything, see, second element is 0. So 0 into anything is 0. So no need to do that. Let us go for the third element in first row, which is 1. So I have to write plus 1 into, leave this row and column. What is left out? This particular part. So 0 into 0 cancelled, minus 1 into this thing. So be careful, minus is there. So minus 1 into 2 minus lambda, so 2 minus lambda. Okay, equated to 0. So let us do the simplification part. Now here we have got what the quadratic form we have got. Otherwise we would have gone by another method also, but since anyways it is fine. So we have simplified this thing and we have got one cubic equation, not quadratic, cubic equation. So in order to solve, you can use the calculator and get the answer. Otherwise, if it is not allowed, you can go by the synthetic division method. So what it says, so we have to bring it in this form. So what you have to do? So whatever is the coefficient of the variables. So here this is lambda cube is the highest power. So that I'll write over here. So 1 is the coefficient, then minus 6 is there, lambda square, then lambda coefficient is 11, then minus 6 is the constant value. Okay. Now here below the first element always it should be 0. Next, coming to this, we have to go by root inspection method. In order to find one of the root, we have to get one of the root by inspection method. So how to do the inspection method? Start with plus 1, minus 1, plus 2, minus 2, plus 3, minus 3, so on. Substitute in place of lambda that values plus 1, minus 1, whatever. If we are getting the RHS side 0, then it is one of the root. For example, if I take 1, if I substitute in this one, so what happens? 1 cube minus 6 into 1 square plus 11 into 1 minus 6 equal to how much we have to find, right? So how much we are getting? 1 minus 6 plus 11 minus 6, right? So how much it is? It is 12 minus 12, which is equal to 0. That means 1 is one of the root of lambda, because lambda is having 3 roots. One of the root is 1. So I can take here 1. Yes, I can take. Next, carefully you have to understand synthetic method. So 1 plus 0 you have to do. It is always the number itself, 1. Multiply this root with this one right below the next number. So 1 into 1 is 1. Add both. So minus 6 plus 1 is minus 5. Then multiply 1 and minus 5 right below the next number. So minus 5. When I add both, how much I am getting? As 6. Then multiply 1 with 6 right below the next number. You are getting it as 6. Add both. Minus 6 plus 6 is what? 0. Always remember you should get it as 0. So here the last element you should get it as after adding 0. That means this is one of the root already we know. And what is the necessity of doing this? What is the necessity of doing this procedure? See, we are getting some values over here. This you have to consider. From this we will form the quadratic equation, because we had cubic equation. We solved using cubic synthetic division. We got one quadratic. How to do that? See here. This is lambda cube. This is lambda square coefficient, lambda then constant value. Decrease one power, and here it will be lambda square, lambda and constant value. Simple. So this one will be the lambda square coefficient. So it will become lambda square, 1 lambda square minus 5 lambda, okay, plus 6 equal to 0. This is the quadratic equation formed from the synthetic division method. Okay. This particular can be solved using the factorization method, or you can apply quadratic formula. So 1 into this constant 6. So while multiplying I should get 6 as the answer. While adding I should get minus 5 as the answer, right? So 6 factors I can take 2 and 3. So 2 and 3 uh, can be taken. So lambda square minus 2 lambda minus 3 lambda plus 6 equal to 0. So when you see this, minus 2 minus 3 is minus 5, minus 2 into minus 3 is plus 6. So everything is satisfied. Now we can take the common grouping can be done first. So lambda can be taken common. So lambda minus 2. Here also lambda minus 2 should be common. Outside minus 3 can be taken. So lambda minus 2 is our common. What is left out? Lambda minus 3 equal to 0. Here multiplication factor. So lambda minus 2 equal to 0 and lambda minus 3 is equal to 0. From this lambda value can be taken as 2. From this lambda value can be taken as 3. So we have got the lambda values 2 and 3. So how many total lambda values will be there? First value we took 1, then 2, then 3. 3 lambda values. These are nothing but the eigenvalues. Next, eigenvalues finding out we got. Now we have to go for the eigenvector. So each eigenvalue will be having corresponding eigenvector. So some procedure has to be followed. Let us do that first. So step 2 is done. We have found out the eigen value. Now we will go for the step 3. Step 3 is basically to find out the eigenvector for corresponding eigenvalues. That form how to find a minus lambda I into x matrix equal to 0. Okay. So a minus lambda I, we have already seen the matrix over here. This is nothing but a minus lambda I. This you have to copy paste over there, right? And you have to multiply with x matrix. We'll see what happens. So x matrix can be taken as what? X, y, z, or x1, y1, z1, whatever you need you can take. 0 is basically the 0 matrix, column wise you have to take. Okay. Now this is the form. For first eigenvalue will start. So eigenvalue lambda is equal to 1 will start. Okay. So in place of lambda, you have to substitute 1. So 2 minus 1, 1, 0, 1, 0, 2 minus 1, 1, 0, 1, 0, 1. So from this, we have to form what? 3 equations. How to form 3 equations? Let us see. First equation will be formed first row into this column equal to 0. Second equation, second row, column, second element. Third row, column, third element. Okay, so 3 equations will be formed. So we'll write those 3 equations. So first one, x plus 0y plus z equal to 0. Second equation, y x is 0, so 0x plus y equal to 0 we have got directly. Then x plus z is equal to 0, the third row from that we got. So 3 equations are formed. Let me just name it as 1, 2 and 3. So from this I need to get the value of what x, y, z. Okay, so 2 equations are same. Y is anyway 0 and x plus y. So how to do? X plus y is equal, x plus z is equal to 0. So x is equal to what? Minus z. Now what you need to do? Always bring the coefficient of both the variables as what? 1. Plus 1 I need. But here minus is sitting. So I will divide with what? Minus sign. When you divide, you should divide both sides, right? So minus minus cancel. Now, so what is left out? X by minus 1 is equal to z by 1. Done. Whatever is below the variables, that will be the value itself. That means here I need to get the vector. So it is x, y and z vector for the corresponding lambda value 1. So whatever is below x, minus 1 is sitting, so minus 1. Y value is directly 0, so no need to bother, directly write 0. Z value is again 1. So this is the eigenvector corresponding to lambda value 1. Let us go for the next lambda value, which is 2. So here I am going to take what? Lambda value as what? 2. So lambda value 2. So what happens? So 2 minus 2 is 0, 0, 1, 0, again 0, 0, 1, 0, 0. X, Y, Z equal to 0, 0, 0. From this also 3 equations will be formed as we have studied. First row into this column equal to this element. So it is 0x, 0y and z. So z is equal to 0. First equation. So I'll name it as fourth equation. Next. Second row anyways no use. 0, 0, 0 everything will be there. Third row. So I'll be getting x as what? 0. Here no need to write equation because directly the value has come. Now y value we don't have the equation, right? That's the problem here. X value we got it, Z value we got X value, Y value we have not got. Since both the values are 0, we can take it as arbitrarily the Y value as 1. Now this is very important case where the both the values we have got, both the variables we have got it as 1. So we can choose Y can be chosen as what arbitrarily, say we can say that Y is equal to 1. So it's not it over here. So whenever two values are becoming 0, the other value you just take it as what? 1. So the vector becomes what? X, Y and Z. X value 1, sorry 0, Y value 1 and 0. Because if you take everything 0, then it is like a meaningless thing, right? So that's why I have taken Y value as 1. This is with respect to lambda is equal to 2. Lambda is equal to 3. What happens? 2 minus lambda minus 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1. Now here also three equations can be formed, right? So first row into this column, so it is minus x plus z is equal to 0. Let me just name it as sixth equation, or 6 we have already taken, not taken, or anything is fine. We'll name it as seventh equation. Okay, next. Second row into this column. So 0x minus y is equal to 0, right? And third row will be getting x plus x minus z is equal to 0. Okay. Now first two, so y value anyways we are getting it as 0. What about x and z value? That is important. If you take 1 and 2 are both 1 and 7th and ninth equation both are same. Okay. So you can take any one, 7th or ninth. So let me just take ninth one. X minus z is equal to 0. Now if you are getting confused, I'll take 7th one also. Okay, so minus x plus z is equal to 0. Now you take x is equal to y. Okay, so always remember when you're taking this, we have studied in eigenvalue and eigenvector. If you have not understanding here, kindly see that video. Everything minute details is explained in that video. Okay, so always bring it in x equal to variables equal to form you have to bring. Then coefficient of both should be 1. That's it. So here it is 1. So denominator part we can take it as 1 1. Okay. Now here also if you observe minus x equal to minus z. So both are having minus minus, just cancel it off. So what is left out? By 1 by 1. That's it. So both the cases are same thing only. So x value 1, y value z value 1, and y value becomes what? 0. So you can write the eigenvector as, this is corresponding to lambda value 3. Now we are going for the step number 4. Okay. So we are going to find out the canonical form. Canonical form. So for that purpose, what we are going to do, we are going to find the D matrix. D matrix is very important. Then only we can find how to find D matrix. That is quite simple. See here, the D matrix is equal to what? We are bothered about only the diagonal value. Diagonal of, see, D matrix is what? Diagonal matrix. Diagonal matrix will be having the diagonal elements only. Other elements will be 0. Okay. So the diagonal elements we can consider it as lambda 1, lambda 2, lambda 3. So we don't need to bother about what is diagonal matrix and all. Okay, in the previous case where we studied congruent transformation, there we found out the diagonal matrix. Okay, from that we got the canonical form. Here directly without seeing the diagonal matrix, just write diagonal elements of diagonal matrix lambda 1, lambda 2, lambda 3. So diagonal matrix will be having the diagonal elements which will be lambda 1, lambda 2, lambda 3. That's what we are considering here. Okay. So what is lambda 1, lambda 2 and lambda 3? So the whatever the values you got of lambda eigenvalue, that you have to write. So that becomes diagonal 1, 2, 3. We got 3 values 1, 2 and 3. That we wrote it. Now what about the canonical form? From this we can write canonical form. Canonical form is quite simple. What you understand? Lambda 1 into y1 square plus lambda 2 into y2 square plus lambda 3 into y3 square. Simple. So what is lambda 1 value? Just we now we wrote, so 1. So 1 into lambda 1 y1 square, so y1 square plus 2 into y2 square plus 3 into y3 square. Simple. This is nothing but the canonical form. Now we have to get the orthogonal linear transformation thing. That is the step number 5. We'll finish this problem. Now the orthogonal linear transformation will be of the form x is equal to py. Now what is x and y? That is the question. X will be a column matrix which will be having x1, x2, x3. Okay, this x1, x2, x3 is related to what? Related to the quadratic form which we had in the question, is equal to P matrix. What is P matrix? That is very important. P is the model matrix. We call it as modal matrix, which we studied in what? Diagonalization process. Right? Diagonalization, whatever process we studied, in that we have studied about the modal matrix. where we used to write diagonal matrix as what? P transpose into A into P, right? Where P is the modal matrix, A is the given whatever the question given matrix, and D is the diagonal matrix. Now here how to form P matrix, that is quite important. Let us learn how to form the P matrix. So we are having three eigenvectors, right? So we have to utilize everything. Why we are finding eigenvalue and eigenvector? Eigenvalue we found out to write what? Canonical form. Eigenvector we are finding to write what? The orthogonal linear transformation. Okay. So here, let me just see the eigenvectors. So we are having three eigenvectors associated with three values. Let me just name this particular thing as last one x3, the second one x2, the second vector, and third vector, let me just name it as what? X. So first one x1. Okay, so x1, x2, x3, we are going to copy paste over there. So x1 matrix, the vector eigenvector we got it as -1 0 1. x2 matrix vector eigenvector 0 1 0. x3 1 0 1. Okay, that part is done. Now using this eigenvector, we are going to form the P matrix, modal matrix. Okay. So we are going to normalize these vectors. Eigenvector, what we have got, we are going to normalize. How to normalize? That is quite simple. What you need to understand, just to take the square root of, for x1 I am telling, square root of whatever the elements is there, add them up. So -1 square plus 0 square plus 1 square. So square it. So how to find? For x1 will start square root of each element you square and add them up. -1 square plus 0 square plus 1 square. Okay, -1 the whole square. Okay, now for x2 again the same thing, 0 square plus 1 square plus 0 square. x3 same thing, 1 square plus 0 square plus 1 square. So what is the answer of this? Square root of -1 square is 1, 1 plus 1 is 2, so you are getting 2 as the answer. You are getting root 2. Next, coming back to this, you are getting root 1. Root 1 is 1 itself. Now here you are getting 1 plus 1, root 2 again here. Okay. So when you are writing the element in P, so how to form the P? Let me just write over here. So P will be formed like this. Okay. So you have to carefully see. First one x1 matrix, x2 vector, x3 vector. Column wise you should paste it. But before pasting, that's why I said normalize this vector. Whatever the element is there, suppose I am writing -1 0 and 1. So I cannot write here -1 0 and 1. What I am going to do, just divide it with the square root of this thing. So square root of 2, square root of 2, square root of 2. Simple. Now 0 by square root of this thing is 0 itself, so no need to write, just write 0. Okay. Next, x2 vector here having 0 1 0. Below that should be 1. So anyways it's the same thing, 0 1 0. Third vector you can see 1 0 1 divided by what? Each element root 2. So it will be 1 0 1 by root 2. 0 by root 2 is 0. Then 1 by root 2 again. So I hope you understood. What we are doing, we are normalizing the vector. So just take square root of each element. So square root of sum of square of those elements you have to take and divide with that elements. Okay, that's it. So P matrix we got. Now we have to bring it in this form. X is equal to Py. So X is equal to Py in the sense what? This is nothing but P. We have to multiply with Y. So what we can do? X matrix, as I said, it is x1, x2, x3. P matrix, just we now got this particular matrix. Into Y. What is Y matrix? It is y1, y2, y2, which we got it from where? Canonical form, you remember. Here we use y1, y2, y2. Okay, that particular thing we are writing here. Now, from this, the equations can be formed. How to form the equation? Same thing. first row into this column will be equal to x1, right? So x1 equal to minus 1 by root 2 into y1 plus 0 y2 plus 1 by root 2 into y3. Done. Next, x2, if you see, second row into this column equal to x2. So x2 becomes what? 0 into y1 plus y2 plus 0 y3. Next, x3 becomes what? Third row, this column equal to x3. So 1 by root 2 into y1 plus 1 by root 2 into y3. So this is nothing but what? X equal to py is the orthogonal linear transformation in which we have got the values of x1, x2 and x3. Okay, this is the final answer.